Good morning, kids. Today's class we are going to discuss the alternating current in one shot, a brief revision of alternating current. It's again one independent topic. It's not like something we are going to use this alternating current in every chapter, an independent topic, one question all the time for JEE mains and also the JEE advance. So first we are going to how to utilize this. One question, only one question. Sir, how to study for this? What is the methodology? How to utilize the one shot? First, watch the video. What all you are having the this one? Watch the video. It will around 1.5 hour, around 1 hour, 1.5 hour. It will be there. Then learn it. All the important concepts which I am summarizing, learn it. After learning, then you should remember all the formulas, all the important ideas which I am explaining here. You have to remember them. How to remember that? Rereading it. When you read it more number of times, 5, 6, 7 times, when you read this chapter, recollect all the formulas, everything, no? Then it will become memory. Then when you solve PYQ, with the clarity of concepts, you know the formula, and as you start solving PYQ, you'll gain confidence, and this is what needed in G means. Okay, fine. There's no any very big magic thing, no need of any inspiration. What you read daily, that is the inspiration, that is the confidence. No need to watch any other inspiration videos, waste of time. Instead of watching inspiration video, better learn this chapter. 1 hour inspiration video, 1 hour watch AC circuit. There'll be a benefit in exam. Okay, fine. Hard work is important. Without hard work, now we want the rank. Not possible. Highly impossible. Whatever you do, it not possible. So, what is a simple thing? Start doing. Start learning. Start learning. Remember things. Solve PYQ. These are the things which will help you to get the best rank very easily. Okay, now how to plan this alternating current in one shot. So here we will be alternating current in one shot. First, generation of AC signal, how that alternating current signal is generated. Those things we'll be learning here. Then how to measure that alternating current signal, that we'll call RMS value. Different shaped RMS, different shaped signals, how to get the RMS value. Then afterwards, when this AC signal connected across resistor, then what is the response of it? Connected across the inductor, what is the response of it? Then when connected across the capacitor, what is the response of it? Then which elements among them will dissipate power, which will not dissipate power? There's a power factor. Then RL circuit connected across AC signal. What about the power dissipated? How? What is the phase angle, power factor? These things. Similarly, RC circuit, response of RC circuit. Then RLC. Then we'll discuss the series resonance, bandwidth, power factor, all the quality factors. Hmm? Okay, fine. Then we'll go for response of parallel RLC for pure AC signal. Response of parallel RLC, that one means parallel circuit also, just we'll have the brief discussion. Then we'll go for transformer, one very important, simple formula based. Like this you have to plan. So after learning all these concepts, then set of formulas are there, you have to remember, solve PYQ. These are all the topics which you are supposed to work out here. So I'll start with the first, well, the generation of AC signal. This particular thing will start it. The generation of AC signal. These are the bar magnets. These are the magnets which will provide the magnetic field. Here the magnetic field B bar. There's a coil. This one is a coil which I'm going to rotate. I'll rotate with an angular velocity omega. Then according to the formula, the flux should be equal to Bs. Flux should be equal to Bs cos theta, Bs cos omega t. Rate of change of flux. There are number of turns are there n. So this will become n Bs omega sin omega t. So what is E naught equal to NdS omega? Number of turns, magnetic field, S is the area of cross circle, omega the turn. This particular AC signal we are plotting, so this will become E naught. This will be E naught. So like this a AC signal is there. Then now this particular why it is called as the alternating current? What do you mean by AC signal? Alternating. Next further, I equal to E by R. Why it is called as alternating current? Alternating in direct, in brief, we'll call AC signal. Alternates, no? For every one half cycle, you can see that one. There's a positive half cycle. Next, afterwards, again, we'll get positive half cycle. After negative half cycle, it alternates. So there's a positive, negative, positive. So this is called like a alternating signal, that one. Okay, I get this. So this is about the generation. So the magnitude, this called like a magnitude or amplitude. This particular thing, what is E naught? E naught will call this as amplitude of AC signal. Now, what is the difference between the AC signal, DC signal? If you look at the AC signal, when you connect across the resistor, during positive of cycle, current will flow. During negative of cycle, the current will flow in opposite direction. For DC signal, all the time, the current will flow in same direction. So when you plot this graph, AC signal will be like this. What about DC signal? DC signal all the time okay, fine. So this is the current. All the time, so there's a current, it will alternate, where I is equal to I naught sine omega t. It will change the directions. Magnitude will increase, becomes maximum, then decreases, then it changes direction. Again, the current will be varying. So what is this? This will be a varying current. So therefore, we'll call instantaneous current. This is called like a direct current. Or in general, we'll call this as DC signal. This has AC signal. Next, so what is RMS value of AC signal? How to measure it? So when the AC signal flows through a circuit, its current will be varying. How to express that one? For that, what I'll go for the power. There's a bulb, the same bulb. What is the power dissipated in this bulb? The same power should be dissipated in interval of time 0 to t. So here it will be V equal to Vm I equal to Im sine omega t. An AC current will flow. What is the power dissipated? P2. The power dissipated in both the circuits should be same. P1 equal to, what is P1? I RMS square into R into dt. The same power in a time interval 0 to t, what power is dissipated? Same power should be dissipated across the AC signal. So this will become, R will get cancelled out. RMS square dt equal to I square t dt 0 to t. So therefore this will become RMS is equal to okay, this will become let me write it IRMS square only. So this will become Im square by t 0 to t. No? So this will become integral of sine square omega t dt. Further this will become Im square t solving this. So what is IRMS is equal to Im by root 2. This is what we'll call IRMS. And how much it should be equal to Im by root 2. Here what is the current? The current which flows here. This current, the instantaneous current which is flowing will be Im by root 2. The AC current, when it flows for an interval of time capital T, what heat is generated? The same heat will be generated by a constant current, the DC current. So this particular DC current which will produce same heat as generated by the AC signal for the same interval of time across the same bulb. So this DC current only will call that as IRMS value. So there is one basic formula to find out the IRMS value, or root mean square value of an alternating current. Okay, now first for IRMS value, what is IRMS value of Vm minus Vm? What is RMS value of AC signal? Just now we have discussed, it should be equal to Vm by root 2. Peak value. Peak value is how much? Vm by root 2. Now where is that value of current will be flowing? That value of current will be flowing here. This will be your VRMS. Next, RMS value of sinusoidal with phase. It is having something like this. V is equal to, this is the Vm. Minus Vm. This is something Vm equal to sine omega t plus phi. What is the RMS value of this? The RMS value of this also Vm by root 2. Irrespective of phase, even if it is a cosine wave also. What is the RMS value of it? Just directly remember the same formula earlier what we used, the same formula we should apply. RMS value of half sine wave. How to calculate this one? So here this will be 0 to t by 2, t, 3t by 2, and this is 2t. The RMS value of this half sine wave, actually we'll call this as like half sine wave. This will be equal to how much? Vm by root 2 only. Then if you remove one of the half, this is RMS value for half sine wave. This is also called as RMS value of half sine wave. This is actually full sine wave. This is a half sine wave. Then what is the RMS value of this? Will be Vm. Directly remember this one. For this like a full sine wave, this is a half sine wave. Next we have the RMS value of a square wave. So let this the amplitude be V naught. Then this will become one cycle. We'll integrate like this. V RMS square equal to Vt square 0 to t square of it integral of 0 to t. This will be, we'll break up this one, 0 to t. 0 to t by 2, the value is V naught square. Divided by t. V naught square t by 2 plus 0 plus t. So how much it will become? V naught square by 2. So RMS value of this will be V naught by root 2. Okay, now, so we'll take the next one. This will be, we'll take some values. There's a voltage. This will be like a 2, 3, 2. This value is 1. This minus 1. This will be 2 seconds, 3 seconds. Okay, again, this will be 5, this will be 6. This will become one cycle. There's a step we have to define now. Now VRMS square equal to, from 0 to 3 it is equal to V square so this will be, we'll break up 0 to okay, I'll do one thing, we'll make like this changes. This will be 4, 7, this will be 8. 0 to 4 is one cycle. Calculations will become easier. 2, let this be 1. 0 to 1, the value of the signal will be how much? 3 square dt. Then 1 to 2, the value of signal is 2 square dt. The value of signal from 2 to 3 is 1 square dt, plus the value of signal from 3 to 4 is minus 1 whole square dt, all divided by integral of dt 0 to 4 will be 4. 3 square t 0 to 1. I'll solve it here. VRMS square equal to 3 square t 0 to 1, 2 square t 1 to 2, t 1 to 2, this will be t 2 to 3, this will be 1, 3 to 4 divided by 4. 9 plus 4 plus 1 plus 1 by 4. 15 by 4. So what is the VRMS value will be? VRMS root 15 by 4 volt. This is a method. It's a purely math based, no concept. We'll take the next one. RMS value of a triangular wave. Two. This will be 1. This will be 2. 3. This will be 4. How to find out the RMS value? So we'll define the signal. The current will be I1. I1 will become equal to 3 by 1 into t. This is for time interval. Then same I2 will be negative slope minus 3t by 1. Or this 1 I'll remove it. It's like a slope. 3t plus 6. Then this will be time interval 2 to 1 second. Then we have to integrate. IRMS square equal to I1 square dt 0 to 1, I2 square dt. This will be integral from 1 to 2. This whole divided by integral 0 to 2. Solving this, I'll get IRMS equal to IM 3 by root 3 or root 3 volt. Or in general for triangular wave, IRMS equal to IM by root 3. This is a generalized formula you try to remember. How to find out the RMS value? So first we'll define the current. So let it be I1. I1 is equal to 2 t. This will be for interval 1 to 0 to 1 second. Then I2 will become equal to just minus 1 and will be constant. This will be for time interval 2 seconds to 1 second. Then what is RMS value? IRMS square is equal to I1 square dt 0 to 1 whole divided by 0 to 2. I1 square, this will be 2t whole square 0 to 1. I2 square, this will be minus 1 whole square dt 1 to 2. This will be 2. 4 t cube by 3 0 to 1. This will be t 1 to 2 by 2. So 7 by 6 ampere. This is the this one. So further, what is IRMS? Equal to root of 7 by 6 ampere. I think this is simple integration. If the different parts of the wave is having different curves, then break that integral. So this will become one cycle. Then define the curve. So the curve will be like this. This is actually your curve. This will become one cycle. So break up the limits. Definite integral, concept of definite integral. Define the curve for 0 to 1 second, 1 to 2 second. Then substitute the limit, integrate, we'll get the answer. This will be our answer. You have to, very, very important. It's a purely formula based, and you should remember this idea. RMS value of RMS value of AC plus DC signal. If the particular, how do this signal will be of like this? Huh? Both AC as well as DC will be present. About this point, the signal will be vibrating. So the current will be RMS square equal to I square dt 0 to t. This will become A plus then expanding this one A square b square sine square omega t 2ab sine omega t dt 0 to t. The value of this will be if you get a composite AC signal, there's a method A square plus b by root 2 whole square. Both DC plus AC are present. This is called as a DC component, this is a AC component. When both are present, this is a generalized formula, try to remember. I'll give one more example. Suppose I will get like composite signal of like this 4 plus 4 sine omega t plus 6 sine 3 omega t. Then what is the RMS value of this? Will be root of 2 square 4 by root 2 whole square this RMS value. Kids, now will come for the elements. Now I'll connect a resistor across this AC source. Then, so what is the power dissipated, how voltage and current are related, those things we are going to analyze here. So what is the source I connected? V equal to Vm sine omega t. Then applying the Ohm's law across the resistor. Vr is equal to I into R. What is I is equal to? I is equal to Im. Okay, first I'll start like this. The instantaneous drop across resistor is equal to I into R. What is further I is equal to? Im sine omega t into R. There's an instantaneous drop. There's a drop across the resistor. So what is the current through this circuit will be Im sine omega t. Then for what is the Ohm's law? Vm equal to Im into R. Vrms is equal to Irms into R. These are the Ohm's law across the resistor. Then we'll come for this one. What is the expression for power, instantaneous power dissipated across the resistor R? Vm sine omega t, Im sine omega t. These are the, you can see the power one. This is the voltage. Then there's the current curve, red color one. The pink color one will be the power. How do we can draw such curves? And voltage and current will be in phase across resistor. V and Vr and IR will be in phase. So sine omega t, sine omega t. Let me substitute. What is the power? Voltage into current, substituting Vm sine Im sine omega t. Then Vm Im sine square omega t, it will become. Then I'll adjust 2 on both sides, solving. Then I'll get the instantaneous power. This is. Then if I take the average value of it, the average value will be Vm Im by root 2. The average value of this function will be 0. Then we'll get the average power. Average power is equal to how much? Vrms Irms. Or which should be equal to average power, how much is equal to Vm Im by 2. This is average power dissipated across the resistor R. Then this is a power cycle. Then voltage and current will be in phase. So across the resistor, what is the condition? The voltage and current will be in phase. Then the average power dissipated in one full cycle will become equal to Vm Im by 2 or Vrms Irms. It will dissipate power. So what this resistor will do, will convert electrical into heat. Converts electrical power into thermal power. This is the meaning of this one. And this is Ohm's law. Vrms equal to Irms-R, Vm equal to Im-R. Now we are connecting the AC source across the pure inductor. This is the AC source. We are connecting across the inductor. Then the current will flow. Okay, fine here. Now the current I will flow. Then across the, there will be drop across the inductor. BL, and this is a current. So we know the drop across the inductor VL should be equal to minus L di by dt. What is VL equal to? These two are parallel, Vm sine omega t. Solving this, di is equal to Vm by L sine omega t. I'll end up with expression for current I equal to Vm by omega L, Vm by XL, where the value of current will be maximum. Im equal to Vm by XL. What is XL? XL is called as the inductive reactance. And what it does, it controls the flow of amount of current and makes current to lag the voltage by 90 degrees. This is a basic idea of the inductive reactance. What is XL? Called as inductive reactance. What it does, it controls the flow of amount of current. How much of current you want to control through the inductor? Yes, you can control it. Then it makes the current to lag the voltage. So I think some new element we have brought it. Earlier, how to control the flow of current? The flow of current we used to control by Ohm, by only the resistor. Now we are having the inductor also. What it does, it will control the flow. So it will make the current to lag the voltage. So across this inductor, if you see this, across this inductor, the current lags the voltage. By how much? By 90 degrees. So what inductor does? It will control the flow of current and also it will make the current to lag the voltage. It's the difference between the resistance inductance, inductive reactance. So here it is. This is a very important. Rest all mass is there. We can manage. I think it's clearly visible now. It controls the flow of amount of current and will make the current to lag the voltage. Therefore, this inductor will do. So here there's a voltage. So what will do? It will make the current to lag the voltage. Here applied voltage is having 0 phase. What about the current? Current will lag. Then Here we'll go for the current equation. I equal to Im sine omega t minus pi by 2. It will make the current to lag the applied voltage. Okay, then power equal to V into I. Substituting Im, solving this plus pi by 2. Current lags the voltage. It should be negative sign here. Vm Im sine omega t cos omega t, this is equal to, then solving this, or the average power will be 0, means it will not consume power. The source will supply, energy will return back, again source will supply, will energy will return back. This is what happening. It will not consume power. You can see here, okay, it will draw the power from the source, return back, draw the power from the source, returns back. So what is the inductor? Inductor is the element which will control the flow of current without dissipating power. This is the basic. It will make the current to lag the voltage. So it controls the flow of amount of current and it makes the current to lag the voltage. So what is the expression for current through the inductor, which will become equal to Vrms by XL. Further, what is XL? XL equal to omega L. So now, how do I can control the flow of current? By varying L and omega. For resistor, only R you were varying. Now, by varying frequency also, we can control the flow of current through the circuit. A new idea here we are generating. And will it dissipate any power? No. Average power is 0. Dissolve. So here IRMS depends on omega and also the L. We'll take the next one. Response of capacitor for pure AC signal. So here it will, current will, I'll supply AC voltage V equal to Vm sin omega t connected across the capacitor. Current will start flowing, instantaneous current, where I is equal to V, no, Q is equal to C into V. So differentiating this, dq by dt equal to derivative of Cv. Further, what is dq by dt? Dq by dt is what? I. So I is equal to C dV by dt. Cvm will come outside. Derivative of sin omega t will be cos omega t. Rewriting everything will get expression for current. So this is called like capacitive reactance. Further, this will become Vm by omega c. What is x equal to 1 by omega c? Then expression for current is this much, Im sin omega t plus pi by 2. So what is a capacitor? Capacitive circuit where the current will lag the voltage. Now we'll come for the power, instantaneous power concept. Power equal P into Vi. Im sin of P is V is instantaneous voltage, Vm sin omega t. Current is how much? Im sin omega t plus pi by 2. Then again average power will become 0 here. If you go for average power, will become 0. So with this, what we can say, that one in the capacitive circuit is 0. So what is the capacitive circuit? It will not consume power. So what it does, I'll summarize here. IRMS equal to Vrms by Xc. What is the inductive? Capacitive is equal to 1 by omega c. So this will become Vrms So we can control the flow of current by varying the frequency of source and the capacitance, and it will make the current to lag the voltage. So this is called like a capacitive reactance. What it does? It controls amount of flow of current and makes current to lead the voltage and will not dissipate power. Capacitor inductor will not dissipate power. What they will do? They will control the flow of current, and at the same time they'll introduce phase angle between current and voltage. Next we have the response of RL circuit for pure AC signal. We have connected AC source. This AC source is connected across the resistor. Here the current high will flow. I or IRMS. This current will flow. We know across the resistor current and voltage are in phase. So we are across and they are in series, so the current will flow like this. And the voltage leads the and the current lags the voltage or voltage leads across the inductor. This is the one basic idea. The same IRMS, same magnitude, same phase angle will be flowing through the circuit. Okay, fine. Now I'll bring everything. So first Ohm's law across the resistor. VR equal to IRMS into R. VL equal to IRMS into XL. Then we'll bring all the things here. We'll draw the phasor diagram. From the phasor diagram, directly let me take the arrows. No. How do the IRMS is like this. VL will be like this. Then what about VR? VR will be like this, parallel to it, the drop. This will be VR. Then VRMS will be in this one. So this is the all things. So this will be VL, this will be VR. I'll make IRMS smaller, the arrow of IRMS, let it be smaller. And this will be IRMS, this will be VRMS. Let this be phase angle of circuit. Then if I draw the vector diagram, this will be VR. VL. Then applying the triangle one, VRMS square equal to VR square plus VL square equal to VR square plus VL square. Vector sum of voltages, that's what here. Then further applying Ohm's law, VRMS equal to IRMS into Z for the circuit. Then across the resistor, IRMS square into R square, IRMS square into XL square. This will be reactance. So this will be Z is equal to R square plus XL square. Or if you write in vector form, now we should write things clearly here. Z, what is Z? Called as impedance. Resistance. This is called as reactance. So Ohm's law for circuit will be VRMS equal to IRMS into Z. This is a basic Ohm's law what you should learn. Then if you draw the triangle, this will be Z, this will be XL, this will be R. I'll define tan phi equal to XL by R. where omega L by R. What is phi? Phi is called as a phase angle of circuit. This is called like a lag circuit. Why lag circuit? Because the current will lag the applied voltage. Then what about the average power dissipated? Average power dissipated will be the instantaneous power is equal to V into I. So it will be Vm sine of select here. V is equal to Vm sine omega t. Current lags the voltage, no? So we'll assume like this. Then we'll take the average power. Average power will be P dt 0 to t dt. This everything solving will end up with Vrms, Irms, cos phi, or this is equal to Irms square into R. There will be two currents will be there. There's one more. One very important idea I'll be discussing. Here we'll get the Vrms. This is the IRMS. This is a phase angle. Here we'll get two currents. One current will be parallel to the Vrms, that is IRMS cos phi. Other current will be perpendicular to the applied voltage. So this is called like a wattless current. Volt dissipate power, component of current IRMS cos phi will determine the power. So better treat all voltages, powers, resistance, everything as a vector. What is the trick here? What is the basic idea, trick of this AC circuit? Treat voltages, current, resistance and power as vectors, or we'll call this as phasors, we'll call it. This is one basic idea is what you have to learn here. So what is the impedance of circuit? Impedance of circuit is given by R square plus XL square. So these are the expression for power dissipated. And it's a lag circuit. It will make the current to lag the voltage. We'll take the RL series one. Regarding power, V equal to Vm, Im. Already I did explained it, and the average power consumed will be 0. So like average power consumed will be Vrms, Irms, cos phi, or Vi cos phi, and this is called like a power factor of the circuit. What is the power factor of circuit? R by Z. This one very important quantity will be discussing power factor VR by R or IR by Z. So where do all these particular things will come in the triangle? So this will be VL, VR, VRMS. So what is the power factor? Cos phi equal to VL by VR by VRMS, which is equal to R by Z. So from this triangle we have plotted cos phi, and the cos phi will the power factor will determine how much of power will be dissipated. These are the curves. The voltage and current will be leading, and these formulas are very important. Next we'll take the response of RC for pure AC signal. We applied voltage here, a current will flow. IRMS, here the same IRMS will flow. Here voltage and current will be in phase. What about the capacitor? Current should lead the voltage. So current will have the phase like this only, IRMS. What about the voltage? The voltage across the capacitor should lag. This is a VC. And this applied voltage VRMS. When you draw this vector diagram, there's a voltage VR, then the current also. Then VC will be, I'll redraw it properly. This will be VR, this will be VC, this will be VRMS. And this is the phase angle of circuit. What about the current? The current which is flowing here will be here. So look at the current leads the voltage by what? Phase angle phi. So when you draw this in the vector form, it will be like this. Then the vector sum of voltages IRMS this will be okay. Now what is a tan phi? again we can also draw the vector diagram. This will be R, this will be XC sorry, and this will be Z. Then we'll define cos phi is equal to VR by VRMS, and this is equal to R by Z. This is one basic formula. Tan phi will define like this: VC by VR, IRMS XC by IRMS into R, or XC by R, or 1 by omega C R. This is called like a phase angle of circuit. Then this is called like a power factor. So this is called like a lead circuit. What it will do? It will make the current to lead the applied voltage. These are formulas for complete AC circuit: power factor, phase angle, impedance, resistance, inductance, vector sum of voltages, vector sum of impedances is what you have to remember. We'll see the power. So the applied voltage is Vm sin omega t. The current will lead the voltage. Instantaneous power equal to Vm sin omega t. Then when you take the average power is given by this particular VRMS IRMS cos phi. This is the expression for average power. Then the power factor given by this particular formula. Then you can write the power thing. So here also the wattles current will come. Here the current will lead the voltage. This is about the basic, all the formulas we have to remember. So here we will dissipate the power. Here the power is dissipated by only one element, that is a resistor. IRMS square R, average power, or use formula VRMS cos phi or VI cos phi or IRMS square R. Sir, what do you mean by impedance, resistance, inductance? No idea. Okay, we'll do one thing. Opposes, resistance means opposes flow of current. What about reactance? Opposes flow of current and makes current to lead the voltage by 90 degree. What about impedance? Opposes flow of current. The same thing. The resultant of these two. Opposes flow of current and makes current to lead the voltage by angle. Got the idea now? Resistance will oppose flow of current and will make current to lead the in phase. Current will be in phase with the voltage. What about the capacitive reactance? It will oppose the flow of current and it will make current to lead the voltage by 90 degree. What about the impedance? It will oppose flow of current. It will make the current to lead the voltage by phase angle phi. This phase angle phi depends on what? Tan phi. The phase angle will be R by Z. R by XC. Just like this, we can control the phase angle of circuit by adjusting R and C value or by omega. And the power dissipation also depends on frequency. Okay, now discuss the response of series RLC circuit. So here the current will flow IRMS across the resistor as they are in series. Same current will flow. Then across the resistor, current and voltage they'll be in phase. This is IRMS. Across the inductor, current lags the voltage. Current lags the voltage. So this is the current, and the voltage across the inductor will be in this direction. This is VL. Across the capacitor, current leads the voltage. Current will have zero phase. And the voltage will be like this. Bring everything in the vector form. This is VC. And this IRMS. This is VR. And this will be VL. And let this be VRMS. So in the vector form, okay, everything, so a rough diagram I'll conclude here. So this will be VR, VL minus VC. This will be VRMS. Then vector, taking the vector sum of voltages, street voltages as vectors. Street voltages as vectors. Then we have to take the vector sum of voltages. So this will become VR square, VL minus VC whole square. Applying Ohm's law, IRMS Z whole square, IRMS R whole square, IRMS XL This is the impedance of the circuit. Like this, we can work out the problem. So what is the tan phi? Tan phi equal to VL minus VC by VRMS. So XL minus XC by Z. Like this, we can define. And what is the power factor? Power factor, here we'll draw the impedance triangle also. This is a power factor. Then what is the average power? Average power dissipated is VRMS RMS copper or RMS square R. These are formulas you have to remember. This power factor very very important. This particular thing is called as power factor. And this is a phase angle. So the power dissipation depends on frequency of source also. By varying frequency of source, we can control the power dissipation. Who will dissipate power? Only resistor dissipates. No dissipation. The inductor will not dissipation. Here also no dissipation. This concept is very very important. The resistor will dissipate power, whereas the inductor and capacitor will not dissipate power. So that's why we say no dissipation, means will not consume power. So therefore directly you can write only this one. So whenever they ask you average power, calculate the current flowing through the resistor R and directly RMS square R will give the average power dissipated across the resistor R. We'll discuss some problems. So suppose say if you have like this, there is a circuit, there is an inductor, there is a AC source. Here it is 4 volt, here 3 volt. I want VRMS. So VRMS will be how much? Root of 4 square plus 3 square. Not like 4 plus 3. Vector sum of voltages. This will be 5. Getting this? If the drop across the inductor is 4 volt, drop across the resistor is 3 volt, then what is the applied AC VRMS value? Not 5, 4 plus 3, 5. It will be root of 4 square plus 3 square. This is the concept try to learn. Rest everything we can manage. Similarly, the same thing across the capacitor in RC circuit. Let this be 10 volt. Let this be 6 volt. How much of voltage across resistor? Then you can't write 10 equal to VR plus 6. 10 square. This is VRMS. So what is the basic method? VRMS square equal to VR square plus VC square. 10 square, VR square, 6 square. 100. It is not something like a 8 plus 6, 14. No. 10 volt, 10 square equal to VR square plus 6 square. Vector sum of voltages what you should do. Similarly, we'll go for how much of VRMS, not vector sum of all. Then what you should do, this is VR, this is VL, this is VC, and this VRMS. So how the vector diagram will be? The vector diagram will be, this will be VL, this will be VC, This will be VR, and somewhere here VRMS. No, vector, you can check it here. And the current will be same, IRMS, you can write it. So the vector form of this will be further VRMS square equal to VR square, VL minus VC square. VR is how much? 3 square. This will be 6 minus 2 whole square. 3 square plus 4 square. So how much VRMS equal to 5 volt. You should not add up again 3 plus 6, not, and it's also wrong. 3 square, 6 square plus 2 square. No. 6 minus 2 whole square plus 3 square. This will be VRMS. And applying the Ohm's law across the individual things. Suppose here IRMS equal to 2 ampere current. How much of IRMS? 2 ampere. Can we find out those values, sir? These values can we find out? Then I want this value of R, L and C. This is 50 years, sir. Can we get all those unknown things, sir? We know VR equal to IRMS into R. VR is how much given 3, IRMS is how much 2 into R. R equal to 1.5 ampere. Then the drop across inductor, IRMS into XL. This will be 6. IRMS is how much? 2 into XL. XL equal to 3 ohm. VC is equal to how much? 2 volt. IRMS 2 into XC. XC will be 1 ohm. Then you can calculate the impedance. Then average power dissipated. Next we have the series resonance. Here the current will flow, IRMS. Their series same magnitude and phase angle. Across the resistor, this will be. Let me draw that one. Okay, this is the current. The magnitude of current. You should have same magnitude and same phase. So zero phase will be there. So this is the IRMS. Then across the resistor, voltage and current increase. Across the inductor, current leads the voltage. Across the capacitor, current lags the voltage, or the current leads the voltage. Voltage lags the current. This everything will bring it in the vector form. This will be resultant. What about this value? This is VR. This IRMS. So applying this tan phi. No, we'll apply the vector sum of voltages. VRMS square is equal to VR square plus VL minus VC whole square. Applying Ohm's law, IRMS into Z is equal to IRMS into R whole square, IRMS into XL minus IRMS into XC whole square. IRMS will cancel out. Z is equal to R square plus XL minus XC whole square. Then what is IRMS is equal to? VRMS by Z. So at one instant, the current in the circuit will be maximum. I'll be varying this frequency of the source. The frequency of source, I'll be varying it. Then where the current will be maximum when XL equal to XC. XL equal to how much? Omega L. Omega square equal to 1 by root of LC, or F equal to 1 by 2 pi LC. We'll call this as resonant frequency. At this instant, the current through the circuit will be maximum. Then who will deliver power? The source will deliver power. Supplies power. The whole circuit will dissipate power. Now the source, this is called like a source, it will supply power. When the circuit will accept that maximum power at resonance here. The resonance frequency depends on what? L and C. This is a basic concept. So here we are bringing that one. As I increase the frequency, so here we'll first discuss this one. As I increase frequency, the inductive reactance will increase. The reason for that, we know XL is equal to 2 pi Fl. X equal to 1 by 2 pi Fc. And X is equal to 1 by 2 pi Fc. So as we increase the frequency, the inductive reactance will increase. As we increase the frequency, the capacitive reactance will decrease. At one instant, both will be equal. At that instant, the current through the circuit will be maximum. And this particular thing is called like a resonance. Okay, fine. Then initially what will happen? Initially at this particular point, the total impedance will be capacitive. Then the current should lead the voltage, the curve. At resonance, the current and voltage will be in phase. And after resonance, when the frequency of source more than resonance, the current lags the voltage. And the impedance will be, total impedance will be inductive impedance. There's a basic idea. At resonance, reactance of circuit will become zero. And the resonant frequency Fr is given by 2 pi root of Lc. We also call F naught. Then like a bandwidth will define. So it's like a where the power will be off of the maximum. Then Z equal to root 2R. I'll solve it, I'll get the lower cutoff frequency. Similarly, where the power will become off of the maximum, higher cutoff frequency. Then this particular bandwidth is what we define. So what is the bandwidth here will be Fr resonant frequency by quality factor, or Fh minus Fl. This is called like a bandwidth. Solving this, we'll get the bandwidth equal to this much. So what is the bandwidth will be? So this quantity will get eliminated. Bandwidth equal to how much will become R by bandwidth is equal to Fh minus Fa. Fh equal to how much? Omega h by 2 pi. So this will become 1 by 2 pi. Omega h will be R by 2L minus of R by 2 pi L. This is the bandwidth. So the bandwidth here, so what is the bandwidth? Where the power will be off of the maximum. Okay, those things will be useful. The bandwidth depends on this quantity. Next we'll define quality factor, which will be XL by XR. So like this, these are about the things which you have to remember for series resonance. And at resonance, there will be maximum transfer of energy from source to resistor will take place. At resonance, maximum transfer of energy takes place from source to circuit. This is a basic idea. Okay, now as we change the value of R in the circuit, what is the value of R? Here, this one. As we change the value of R, what will happen to the flow of current? Yes, the flow of current depends on the frequency. What is the frequency here? It will be like this: Bm sine 2 pi ft. By varying the frequency of source, we can control the flow of current. We can control the flow of current. We can control the flow of current. So for a high value of resistance, the current will be very low. For low value of R, current will be very high. Next, we'll go for response of parallel. If there are parallel circuits out there, then what should be the approach? Here, the drop which is applied, Vm sin omega t. The drop will remain same, Vrms. And we know the current flowing here will be I1. Let the current flowing here will be I2. What about this is the R and L. And we know the power factor for this one, tan phi 2 XL by R omega L by R. So then what is the expression for I2? I2 should be equal to Im, so I1, I2 sine of omega t minus phi. Current lags the applied voltage. What about I1? I1 will be I1 into cos omega t. What about this phase angle? Phase angle. So what about I2 now? How to calculate I2? I2 will be given by Vm by Z2 or Vm by root of R square plus XL square. What about I1? I1 will be Vm by Xc. Then taking the vector sum of these things. The vector sum of these currents. So this we can also write it as Im sine omega t plus pi by 2. Then we have to do the vector sum to get the total current IRMS. But here also who will dissipate power? The power is dissipated by only I2 square R, average power, because the capacitor will not dissipate power, inductor will not dissipate power. Then if you solve this, this will be the overall I1 is like this something. I2 is somewhere I2 sine omega t minus phi. This is Vrms. Then take the vector sum, we'll get the current I1. So we'll get the current IRMS. When parallel comes, this is the method we have to apply it. We have to take treat the current and voltages as vectors. Now similarly one more example. If we get like this a circuit, then how to solve this particular problem? Here applied voltage Vrms 0 phase, we'll assume that one. Here current I1 will flow. Resistor R1, capacitor C. Here resistor R2, inductance L. Here the current here will be flowing is I2. So first we'll write expression for I1. I1 will be capital I1 sine of omega t plus phi 1. What about I2? I2 will be I2 sine of omega t minus pi 2. Why in positive sign here negative sign? RC circuit is a lag circuit. Current makes the voltage to lead. RL circuit, current makes the voltage to lag. It will make the current to lag the voltage. Then what about I1? How to calculate I1? I1 will be VRMS by root of XC square. What about I2? VRMS. Okay, this will be VM, peak voltage. R square plus XL square. What is XC value? XC is 1 by omega C. What about XL? XL equal to omega L. Then what about the phase angle? Tan phi 1. Tan phi 1 should be equal to XC by R1 or 1 by omega C R1. Tan phi 2 XL by R2. Then what about average? What is the total current? The total current will be like this. Huh? This is VRMS. This is the VRMS, applied voltage VRMS. This current I1 will lag. What about I2? I2 will lag. I1 will lead. Okay, then what is I is equal to vector sum of these two. We have to take the vector sum. I bar equal to I1 bar plus I2 bar. Then what about average power dissipated? Average power dissipated should be very simple. Okay, agreed? There is a generalized approach you have to develop here. Next we have the topic transformer. So it's like a secondary coil, I'm wounding it. Primary coil, I'll wound it, number of turns P. Here secondary coil, I'll wound on it here. This is like a transformer core. There's a magnetic material. Then what all flux link? The same flux is made to link here. There's a basic idea. Then we know from Faraday's law, EMF induced like a EP or VP. These are the symbols. ES equal to VS. EMF induced across primary, secondary, VP, V voltage. So this should be equal to number of turns d phi by dt. Then the EMF induced across the secondary, number of turns into d phi by dt. So what we are making the rate of change of flux linking will be constant. You can see how many lines of force, 1, 2, 3. Same 3 lines of force are made to link. So therefore now equating this EP by NP is equal to ES by NS. When a current through this primary coil, if it is varying, and what it does, it will produce variable magnetic field like a solenoid. It will produce a magnetic field here, B bar. The same B bar will propagate and will come. So now the B bar linking this coil will vary. Then according to the Faraday's law, flux linking the coil, various EMF will be induced. Then the EMF induced across secondary given by this one. I'll see that rate of change of flux linking the coils remains same. Then we can write it here. Then there is no power dissipation by the core. What all the power we have supplied, the same power will appear here. Power across primary equal to power across secondary. What is the power? How you define? Voltage into current. Voltage into current. So therefore EP by ES is equal to IS by IP. So therefore what we can write? EP by ES is equal to the practical transformer. If you look at this particular core, like it turns, number of turns, there's a wire, copper wire. This will have number of turns. The copper wire will have a resistance, and that resistance is what we'll call R1, resistance of the primary, you can call it. Similarly, the secondary coil also will have number of turns. It is made up of copper wire, so it will have also have resistance that will call resistance of secondary. Then we have applied voltage. Here will come the primary voltage. This will come secondary voltage. This is applied voltage. Then what is the primary voltage? Primary voltage is given by V1 minus R1. This is the primary voltage. And E2 is what? Secondary voltage. Here we'll expand further. This will become EP equal to V1 minus what is I1? I1 will be primary current, and this is resistance of the primary RP. Then similarly ES minus this will be IS into RS. This is output voltage. This is the input voltage. Then here we'll get relationship EP by, so what is the ES? ES is equal to EP into NS by NP. This is a basic relationship. Not like V1, V2 are not related. E1, ES, this one, primary voltage across, like the voltage drop across primary, secondary will be related to number of turns by this formula, not V1, V2. V1, V2, again we'll apply the Ohm's law. Like, what is V1? The input voltage V1 equal to drop across this plus drop across this one. This is one basic method what we follow it. This is V1 is input voltage and V2 is output voltage. V1, V2 we don't have relationship. So first what I do is like I'll apply the input voltage. I'll calculate the drop across the primary. Okay, fine. Then I know the number of times I'll get the drop across secondary. I'll substitute here. I'll get the output voltage. This is very, very important. We can't try to V1 N1 equal to V2 N2. What about the currents? Currents will be inversely proportional. Suppose say IS is equal to IP into NP by IS. Like this, the currents will be related. This will be practical transformer. Ideal transformer, this R1, R2 will be 0. If R1, R2 0, then E1 will become equal to EP equal to E1 and ES will become equal to V2. We have to understand the basic concept. This will become, I'll do one thing, I'll write it here. There's a practical transformer. There's the ideal. For ideal transformer, we can write like this, these things. But the same formula should be utilized for this one. This is output voltage, V2. So you should not write, this equation will be wrong. V2 is equal to V1 into number of turns, like N2 by N1 or NS by NP. This is a wrong thing. Agreed? So these are some problems are available in JEE mains, so you have to be careful. Now, types of transformers. We have the step down, step up transformer. Step down in the sense like NS will be NP, will be less than NP. So therefore, ES is equal to EP NS by NP. So therefore, ES will be less than EP. Similarly, step up transformer. Step up transformer means NS greater than NP. Then here what we get, ES equal to EP NS by NP. So based on this, ES will be greater than EP. If you want to bring down the AC voltage from 1000 volt to 10 volt, step down transformer. If you want to increase from 10 volt to 1000 volt, step up transformer. But what about the current? Current will be inverse, like a inverse ratio will be IS will be IP NP by NS. The same thing here also. Then what about here? As you step down the voltage, current will increase. No? Here IS less than IP. But what about the power? Power in the primary should be equal to power in the secondary. Similarly, here power in the primary should be equal to power in the secondary. Like this, we have the transformers. Huh? Next again, what are the losses? There are many losses are there. What are the losses here? Losses in the transformer. Flux leakage. One. Next, copper losses. What are copper losses? The copper wire, this wire will have resistance. Already we have seen, no? Some heat will be generated. So this copper loss. Flux leakage. The whole flux generated by this may not link it. That's called like a flux leakage. Third one, like a this one heat will be generated because there's a core is made up of metal. A variable current flows, it will be generated. So eddy current losses. These are the primary. How to minimize eddy current? By laminating the core. This is called like a laminated. By laminating what means we can minimize the eddy currents here. Here at this point, the eddy current which are flowing will be minimized. Okay, kids, we had the discussion on the alternating current in one shot. Huh? Almost all the topics I covered it, all the formulas I explained, all the methods I explained. Huh? You have to watch this video, learn it, huh? Rewatch it. Once you have the concept clarity, then remember the formulas, then solve PYQ. You can do the better. Lot of ideas are there. It's not like something very easy chapter. But altogether, some you should understand the basic thing of what do you mean by RMS signal. Okay, fine. Then afterwards, what do you mean by reactance, resistance, impedance, average power dissipated? These are the words I'm using very often. So you have to understand these words. Based on these words only, all our discussion is going on. Current leads the voltage, current lags the voltage. So such key words, try to understand the meaning of them so that the whole chapter will become easier. Now, what are the books you can refer for JEE means? Directly PYQ. If you just solve the PYQ, that will be more than sufficient. After watching this, solve PYQ. Then for JEE Advanced, you can prefer the Singage textbook plus combination of LNs or my DPPs which are present in the app for JEE Advanced. Per chapter, if you can solve around 50 to 60 best numericals related to all, you can manage it. Okay, kids, this is about the alternating current. So one question for JEE mains, one question for JEE Advanced. Very sure, all the time they're asking. And it's like some sort of not something highly conceptual, just like some information. And you should know the keywords. All those keywords, if you are very strong, you can manage this chapter very easily. So all the best, kids. Do well. Prepare. You have to prepare. You have to do hard work. Then only you can get a better rank. Without hard work, not possible. Without effort, not possible. You have to put effort. So start reading, revising, solve PYQs. Okay, we'll bring the next RC circuits. RC circuits in one shot. Thank you all of you. Thank you everyone for great support. Thank you. I'll end up the session.